This is my final video looking at examples of graphing sine and cosine functions. And in this video, we're looking at functions with multiple transformations. And for the first time, we are seeing vertical translations making their way, and we'll see how to deal with those. So first things first, as usual, we need to not transform, we need to just factor out the coefficient of x for the argument inside of the cosine function. So we rewrite this as negative 2 cosine 2 outside of x minus pi minus 3. Now we can deal with it. As usual, we are taking one cycle to graph. We could graph more than one cycle. We could graph half a cycle, but we're just going to take it as one cycle. And if you haven't been told what that cycle is, we should try and figure out something which works quite neatly for us. And we are going to use a period of, not use, it does have a period of, let me see now, 2 pi, the usual cycle length for cosine, divided by 2, and that gets us, that's this 2 here, by the way, of course, and that gets us a period length of pi. So, what are we going to use as our period? Well, this phase shift is minus pi, which means that our graph is going to be shifted to the right by pi. However, the period length is pi as well, which basically means every single length of pi, we are also going to go start our graph again. We're going to recycle our graph. So if we have this, which says the graph is going to go forward by pi, and we have a period length of pi, if I then start my my domain at 0 and then go to pi, that will also capture exactly one period, okay, or one cycle. So that's it looks like as if I've just chosen 0 to pi because that's what the period is, but it's in fact because it is also the size of our shift as well. So effectively I can start at 0 and get one cycle. So let's start the graphing process. And you can see I've got my axes drawn out here and I kind of know where I'm going. So I've actually got my x-axis drawn up fairly high because the first thing we're going to tackle is this negative 3. And we put negative 3 into our graph, like so. 1, 2, 3. Just trying to be a little bit estimatey, like so. And this becomes our new center line. So I'm going to draw in my dashed line so I can see that is where the center of my graph is going to be. I now look at the number in front of the cosine function. I see it's 2, which means that my amplitude is 2, which means that I'll be going 2 units above the center line and 2 units below the center line. So that gives me minus 3 plus 2, which gets me to minus 1, which I think would be about there, and minus 3 minus 2, which would get me to, I think, about there, like so. Might even zoom up so we can see this a little bit more easily. Okay, so I'm going to draw my red lines in here as well. And the nice thing is, once I've done these red lines, I kind of have a decent sense of where to go from here. Okay, the rest of this task is pretty much as we normally would go. We've got from 0 to pi here, and so I've got 0 to, and I'll just plot it in to pi here, like so. Now I halve and halve again like we've been doing with the other graphs. So half of pi is pi on 2. Half of that again is pi on 4, and this is 3 pi on 4 as well. Now, this is a reflected graph. We've got to keep track of all of these transformations all at once, which means that my cosine graph, which normally starts here, is going to start here. It's going to be upside down. So I'm going to put my first dot here, and then my next dot here, and then my next dot here, and then down we go again here, and then finally here. So I'll put all my dots in, and now I do my little curves to join them up as neatly as I can. And fortunately, I say fortunately, but of course I designed it this way. Everything stays below the x-axis, so there's nothing else to figure out. There's my lovely little graph like so, and we're done. Number 2 is another story. Number 2 doesn't have a phase shift this time. I thought I won't make it too complicated, but it does have one more wrinkle in it. Let's have a look at it. It starts off the same kind of process. We go, well, I know the period. The period is equal to 2 pi, the usual cycle length for sine, and divide it by 4, which is this number here, and that gets me pi on 2. So that's my period. I then need to take into account this plus 1 here. So again, the center line gets moved up by 1. So I'm going to make it, say, about here, like so. And then I'm going to take my amplitude and add and subtract the 2 from 1 to get my top and bottom. So 1 plus 2 is 3, so that's going to be about there, and 1 minus 2 is negative 1, so that's going to be about there, more or less. I feel like I might have overblown the top one there, but that's okay. So there's my top line, there's my center line, which is always aligned with the vertical translation, this number here. And our next step is, as usual, to take the period, pi on 2. Sorry, I haven't actually talked about the actual domain. We're drawing over one cycle. I get to choose what it is, so I'm going to say it is from 0 to pi on 2 because that's easiest for me. So I put pi on 2 on one side like this, and then I keep on halving and halving again. So half of pi on 2 is pi on 4, halve again to get pi on 8, half again here, and I get, what do I get? I got 2 pi on 8 going to 4 pi on 8, so it's 3 pi on 8. That took me way too long to think of that one. Okay, so there we have it again, and it's a bit uneven the way I've divided it, but it is a sketch. It gives me a sense of it. Okay, it is a sine graph, so that means, and there's no reflection, so that means we're going to start at the center line here, then we're going to move up to pi on 8, then we're going to move down to pi on 4, then we're going to go all the way down to here, the red line, 3 pi on 8, before returning up to here at pi on 2. Okay, so now I'm going to draw my curves in. One curve, two curves. Oh man, that was bad even for me. Second curve. Oh man, this is my last try. If it's not right, you know where I'm going with. That's a little bit better. Second curve, third curve, and finally my fourth curve. That's an awful graph, isn't it? So stretched on this side compared to the other side, but I'm sure you'll forgive me. Now, are we done? No, we're not done. Why not? Can you think? It's because I have 2 x-intercepts I haven't yet identified. If we're lucky, the question will say that you don't have to identify x-intercepts. So you're now done with your graph. But if it doesn't, you're going to have to work them out. P.S. If you have a phase shift that graphs along this way here with a vertical translation, you might have to work out a y-intercept as well. Luckily, this one is, the y-intercept is just 1, so we're fine. But just keep that in mind, that you do have to work out y-intercepts as well if you need to. Wow, that graph looks bad. Okay, so let's have a look at the x-intercepts. How would we solve it? Well, the answer to that is, well, I'm going to throw the question back at you. How do we ever find x-intercepts? We take the function y equals, 2 sine 4x plus 1, and we set the function equal to 0, and we solve for x, don't we? So if we solve that function there, and we work out the values of x, that'll be our y-intercepts, and we have to do it for x over 0 to pi on 2, because that's basically what we have graphed. Okay, we can do that. It's not necessarily the quickest of things to do without a calculator, but we can do it. 2 sine of 4x is equal, plus 1 equals 0. Subtract 1 from both sides. 2 sine of 4x is equal to negative 1. Divide both sides by 2. We get sine of 4x is equal to negative 1 over 2. Great. Now we have a trig function with an argument equal to a value that we actually do know. But before we do that, we're going to do a quick domain adjustment for solutions purposes. So we're going to say let theta equal 4x. So we're now going to have sine of theta is equal to negative a half for theta between. This is when we just do this in our head. We substitute 0 into x and we get 0 again. So it's from 0 to, and then we substitute pi on 2 for x. 4 times a half is 2, so this is going to be 2 pi. So our new adjusted domain for solutions purposes is 0 to 2 pi. And we go about our process. Now again, we look at sine of theta hat, which is without the sign. So sine of theta hat is equal to a half, without the plus or minus is what I mean on the value. So sine of theta hat is equal to a half. And then I'm going to draw my triangle up really quickly, but you can, of course, refer to your information sheet. That's 1, that's 2, that's root 3. So this is going to be a half from this side here. And that is, because it's half an equilateral triangle, that's pi on 6 up here, and pi on 3 down here, not that I need it. Okay, so it's pi on 6. That gives us theta hat is equal to pi on 6. Wonderful, wonderful, wonderful. Let's move on. We are looking at between 0 and 2 pi. So I can draw out my little unit circle here. That's 0, pi, and 2 pi, which means that we are looking for sine as being negative. So we're going to look at here or here. And we just need to work out what they are, which we can do in a fairly straightforward manner. So theta is equal to pi plus pi on 6. So that's going to be 7 pi on 6. Or we're going to have this one here, which is 2 pi, or 12 pi on 6, minus pi on 6, which will give me 11 pi on 6. So that's all good. And that is equal to 4x. So now I'm going to divide everything through by 4 to get x is equal to 7 pi on 24, or 11 pi on 24. And I can't simplify these, so that's as good as I can get for my values. I'm certainly within my original domain, and it certainly seems to make sense. I'll do it in a different color so you can see it, but it certainly seems to make sense in terms of where these 2 points here are. So this would be 7 pi on 24, and this would be 11 pi on 24. Very squishy diagram there. I'll just do a quick zoom up so you can sort of see it in situ there. So there's my graph, and there is my x-intercepts that we're missing. So yeah, that's putting together quite a few skills there in order to properly graph it. But at the end of the day, each discrete little part, I hope you'll find, is not too shabby. Just don't do what I do and get my halving and halving again so badly out of whack that your graph looks dodgy like this one. I'm sure you can do better than me.